Hey guys, in this video we'll be building this Wheel of Fortune animation in Expo using React Native gesture handler and D3 path along with SVG for creating this pie and some utility functions for random color and snapping into place. I hope that you'll find it useful and let's get started. I already have the Expo project and first let's open up the terminal and add our dependencies. So we will need D3 shape for creating the pie, random color for assigning different color for each slice, and Popmotion popcorn from which we are going to take the snap, which is an utility function for snapping between different degrees. While this is installing, let's import the gesture handler and SVG from Expo. And from the gesture handler, we will need the pawn gesture handler and the state gesture handler. And from SVG, we will need the path, the group, the text, and the tspan. From SVG, and let's also import D3 shape from D3 shape, and also import the color from the random color, and also import snap from Popmotion popcorn. We will start by creating the wheel first. So we will need a variable here, number of segments, which is 10 for now, and we'll create a method make wheel that is going to have data in the first place, which is an array starting from the length of number of segments. And we will map, we will fill with value 1 because we want to have all the slices equally distributed in the pie. And then we will create the arcs, which is a D3 shape, a pie, and pass the data to the pie. And now we need to return the arcs and map through them, and we'll have the arc and the index. Here we will have the instance of the shape, so D3 shape, and here we will have the arc itself. We'll want to build an arc. We want to give a pad angle of 0.01. Also create the outer radius, which is going to be the width divided by 2, and also the inner radius, which is going to be 20 for now. And also get the width of the screen from dimensions. So width is going to be dimensions, get the screen, and also make this as React Native text, because we will have a duplicate from this one here. So now that we have the instance, we can return an object here, and we will have different attributes. So we will have the path, which is instance, and apply the arc itself to the D3 shape arc. We will have a color, and let's create the colors here. So we'll have outside. So colors is going to be color. We will pass the luminosity of dark, and the count is going to be the number of segments. And here the color is going to be colors by the index. We also want to pass the value. So we want to have a value between 200 and 2200. So in order to create that, we need round, and we'll do a random between 1 and 11, and then we will multiply it with 200. And we'll also need a centroid. This will give us the center of the arc, and it's useful when we are going to populate the pi with the value here. So it's going to be the instance centroid, and we pass the arc, and this will give us a pair of x and y coordinates. Okay, so now that we have the data, let's assign it into a variable here. So actually it's wheel paths is going to be the return of this function here. And let's start by rendering the pi itself in the first place. So we will have the render svg here. So render svg wheel, and let's create this method. So render svg wheel, which is going to be a function, and we are going to return the view. This will also have the container style, and we will have an svg, and the svg will have the width of a wheel size, the height of a wheel size, and also a view box. And the view box is going to be 0, 0, the width of the screen and the width of the screen. So we want to make it a square, more or less. And now let's define the wheel size. Let's say it's width multiplied 0.9 for now, and we want to make it a square. Here inside the SVG we want to create a group, and inside this group we will iterate over the wheel paths and do a map here. So we will get the arc and the eye, and we will get the x and y. Actually, it's okay, let's return for now a group here. So now we wanna inside this group we wanna create a path. So the path is going to have the arc path and also fill of the arc color, so the color that we've generated. And let's save it and see what we've got so far. And as you can see, it's like off screen, and that's because everything is starting from 0, 0 coordinates. So you need to center it. First, let's remove the key warning. So key is going to be arc and the eye. And also to align it, we need the main group here to be translated. So we will pass the I equal to width divided by 2, and the x is width divided by 2. And if we hit save, we should be able to see it in the middle of the screen. So that's the first step. The next one is to create the text, which is going to be aligned properly in each slice. So we will have the text from the SVG, and inside this text we will iterate over each value from the arc value. So first let's get the number, and we will have the value, the string, parse it into a string, parse it as a string, and we will create an array from length is going to be number length, and we will map it and receive the I here, and we are going to return tspan, and inside this tspan we'll do number char at the I, and also actually add j here, because we want to create a key that will be equal to let's say slice and j, and also arc I and slice j. And this span is going to have multiple properties as well. So we will need to pass the x and the di. And first, let's get the centroid. So x and y from the arc centroid first. And the x is going to be x, and dy is going to be the font size applied to this font, so to this text. So we will have the font size of, let's say, 26, and also 26 here. So since this is let's add it to a variable. So 26 here, and for the text we also want to apply an x equal to x and y equal to y, and we want to fill it with white and anchor the text the middle. And if we hit save, we should be able to see the values here, but as you can see, they are not properly aligned. And in order to align it, we need to rotate it based on each index. And so we are going to rotate this group. Actually, this text should be placed into a group. And this group here, we can rotate it. So rotation is going to be the index, multiply it with one turn. So one turn is going to be 360 degrees. And this is going to be multiplied by the number of segments. And we'll pass also on a different angle offset. So you'll see in a minute what I'm talking about. And also this one should be in parentheses. So let's create those variables. And the one turn is going to be 360. And we also want to apply different, so we want to calculate the angle by segment here, which is going to be one turn divided by the number of segments. And the angle offset is going to be angle by segment divided by 2, so we'll get the middle of this thing. And since we are here with the angle offset, as you can see, everything is starting from the edge, and we wanna offset the angle. So that's why we created this offset here. And so in order to apply it, we can add also style here. So style is going to be transform and rotate minus angle offset degrees. And if we are going to hit save now, we should be able to see them rotated. And as you can see, the rotation is good, but the origin of the rotation is wrong, and so we need to also apply the origin of the group itself. So here inside the group that we are rotating, we also need to apply origin x, which is equal to x. Actually, it's origin, and here we will have x and y. And everything is starting from the middle, from the centroid, and so we want to transition it above. And so in order to do that, we can subtract 70, let's say. So now everything is starting from this position down. Okay, so now that we've created the pie along with the values, let's now wrap the React Native gesture handler, add React Native gesture handler. And so we will have this this render. The main render is going to return a pan gesture handler, and inside we'll have this this view, and to the pan gesture handler will pass an on handler state change, which is going to be on pan, and we actually it's okay for now. And this on pan is going to receive the native event, so native event, and it's going to do is going to start the animation whenever the state of the event has finished. So if native event state is equal to state end, we are gonna get the velocity y from the native event and start a new animated, so a new animation, so animated decay. And here we will need an angle, let's say, which is a new animated value that is going to start from 0. So we will animate this angle, and we will apply a velocity, which is a velocity y, and we are gonna use deceleration 0.997, let's say, and we are gonna use the native driver through here. And when this is finished, we wanna do something here, so do something here. For now we'll leave it empty. And so whenever this this is going to finish, we also wanna rotate the SVG itself. And so in order to do that, we have to wrap the SVG here into an animated view, and the animated view is going to have a style applied. So let's align items to the center and justify the content to the center, and also apply a transform. And we will add the rotation, and it's going to be the angle, interpolate, and the input range is going to be -1 turn, so 360, 0 and 1 turn, and the output range is going to be -1 turn degrees, 0 degrees, and 1 turn in degrees, 1 turn in degrees. And if we hit save, we have an error here. The problem is that we are importing animated from React Native Reanimated, and so we want to add it from React Native. And when we hit refresh, we should see that the wheel is going to move whenever you move the finger on the screen. So but the velocity is quite high, so we need to divide it by 1000, and now the rotation is moved, and we wanna apply a different deceleration rate closer to 1, and it's going to slowly decrement the speed, acceleration. Okay, cool. Now that we have this this thing in place, disable the pan whenever the animation is running. So first, let's go to the gesture handler here and say disabled is this state disabled, and create this into the state. So first is not disabled, but when the component did mount, we wanna listen to the changes, so add listener, and we'll get the event, and here we'll say if if the current if the state is disabled, actually let's make this enabled and disabled because it's simpler. So enabled is true by default, so if this is enabled, we want to disable it, so we will set state it enabled is false, and whenever the animation will finish, we want to set state with enabled true. So now if we hit refresh, you'll not be able to tap again unless so it's actually this is enabled, so you're not going to be able to rotate it again unless this is finished, so the animation is finished. And now let's also calculate the winner after the animation will finish. So we'll have get the index of the winner, so get winner index based. This is going to return the index of the current position of the wheel, so we will have degree here, so it's going to be the absolute value of the angle modulo 1 turn. So we'll say divide whatever value you have by 360 and get a value between 0 and 360. 59 actually, 359, but we need to set the angle value to here, and whenever we have this event here, we will assign the angle to the event value. So we'll have this one here, and we will return the degrees divided by the angle by segment, and this will give us the index of the current winner. And when the animation is finished, we first wanna do a couple of things. So if the animation now it's finished, we want to first snap into the middle of the current winner, so and set the angle to set the value of the angle to be the current value of the angle modulo 360, so 360, which is 1 turn. And now we want to use snap tool, so snap tool is going to be a snap, and we want to snap 1 turn divided by the number of segments. And with this we want to start a new animated, so it's going to be animated timing, and we want to animate the angle to value snap to the current angle, and we want to animate it over 300 milliseconds and definitely use native driver. And when this is finished, we want to then set state enable true, and here we will also apply the winner to the state. So we set state with the winner, so winner index is going to be get winner index by the angle. Actually we don't need it, we already have the angle, and here we will say winner is equal to this wheel paths and winner index, and we'll get the value here. And we also want to display the value when the animation is finished, so we also want to add finished true to the state, and finished true is going to be false when we start the animation, and also the default value of it, and winner can also be null in the first place. And now that we have everything calculated, we can also render this text here. So we'll have this render winner, and the render winner is going to return a text or React Native text, and inside it is going to be winner is, and then the state, and then the winner. And also let's apply a style, so style winner text, and winner text is going to be a font size of 40, maybe 32. Font family is going to be Menlo, and I think that it's fine for now. And we also, actually this is Menlo capital M, and let's make it absolute and place it to the bottom, so 110. So winner text, so it's going to be styles. And as you can see, we already displayed it, but we want to ensure that the animation has finished and the pan gesture handler is enabled. Then we want to display the winner. So now it is going to snap and is going to show the winner after that. And now when you swipe again, is going to remove the winner and then start the animation. This is great. The only thing that remained is the knob here, and for that I already have the pin here prepared, so the SVG. I'll share the link in the description with you, and I'm going to copy paste everything and create the knob here. So it's going to be render knob, and this render knob is going to return an SVG here, and is going to have the width and a path, of course. The SVG itself is going to be is gonna have the path, and the SVG is going to have a width, height, and also a view box. So set so the view box is going to be this guy here, and the width is, let's round it, so the width is going to be 57, and height is going to be 100. And we also want to render it here in the SVG wheel, so this render knob, we should be able to see this one here at top. The problem is that it's quite big, so knob size is going to be 40, let's say, and apply this 40 here. The height is going to be the ratio, so it's actually it's knob size, so this is knob size, multiply it 100 and divided by 57, and I think that we're good to go with the view box. And also, in order to animate this, let's wrap it into an animated view and render the SVG here. And I think that the knob is pretty big. It's much better now. And we also want to wrap this SVG into a view, and actually it's okay. We can apply some styles here because we want to create a container that will animate starting from this center, so the pin is not going to shake whenever you're animating the rotation. So the style is going to be the width is going to be knob size, and the height is going to be knob size multiplied with 2. We also want to justify the content of the flex end, and since this is a relative position, we want to make it z index 1 to be on top of the wheel, and we also apply a transform here. So transform is going to be, for now, rotate and 0 degree. So we are going to animate this rotation. But first ensure that everything is looking properly, and so if we add a background red here, for example, we will see that we need to move this down a little. So we will apply a transform, and here we will say translate let's say 8, maybe, to be like in the middle. Now it's almost in the center, and we can remove the background and also apply a special fill to the knob. So fill is going to be knob fill, and this knob fill we will use again the color, which is going to be hue is purple, and luminosity is going to be light. So we will always have a different hue color here, so I think that we can also leave it without luminosity. So is knob fill, and for this particular knob we need some animation divisions and modulos here, and we will start by, we need to first subtract the angle offset. So we will have YOLO animation here. So it's going to be animated subtract, and from the angle we want to subtract the angle offset, and now this angle we want to do an animated modulo, and here we will pass one turn. So we want to always be in the range of 0-360, and this once we have this value, we also want to get the division by the angle of segment. So value is going to be angle by segment, and so we will get a range between we will have an index based on how many items are here, and we will have, let's say here we will have between 0 and a number of segments value. But the problem is that we want to have the decimal, because we can end up having 0.67 or something like that, or 2.67, and we want to take this value, which can be of course between -1 and 1. So in order to do that, we need to get the modulo of this value by 1. And so this one will say 2.37 modulo 1 is going to be equal to 0.37. And with this YOLO we will interpolate here. So we'll interpolate, we'll have an input range and an output range, and the input range is going to be between -1 and 1, and the degrees are going to be from 0 degrees to 35 degrees and again 0 degrees. So we want to move it, shake it more or less. And because we want to move before the edge, we want to animate from the left to right and also from the right to left, and so we will need a couple of things here. So we want to animate before the edge, so it's going to be 0.0001 and 0.001 the first place, so it's going to be 35 degrees and minus 35 degrees. And we also want to start the animation in the middle somewhere, so it's going to be 0.45 and 0.45 here as well, and we will have 0 degrees as well as 0 degrees. So this is going to be like a shaky move, as you can see here. We can also play around with the number of segments. So for example, I can also add now 18 and also make the wheel size a little bigger here. So 1.1 of the width. And so you can find always what's convenient for you. So you can also do a bigger size of the wheel. And I hope that you've enjoyed it, and definitely leave a comment if you need any help. I'll be more than happy to help you out. And don't forget to like, hit subscribe and the ring bell button if you want to be notified whenever I'm posting a new video. And see you in the next video, guys. Bye.